Alright, so today we're going to be talking about differentiation rules, and last time we learned the formal definition, right? So it was kind of long and tedious. You had to be really careful with your algebra. And now we're going to kind of talk about ways to make it easier today. So I want to first talk about some other notation. Last class we primarily used this notation here, that f prime of x. We said that that was notation for the derivative. Some other notation, you could really just write y prime, just like that. That's also notation for the derivative. This next one, dy over dx, you would read that as the derivative of y with respect to x. And the last one here is just d dx. It's the derivative with respect to x. So if you see any of that notation, it's asking you for the derivative. Remember, your derivative is just the slope of the tangent line. Okay. Then we also had to be able to figure out the derivative at a specific x value. So these next three are just ways that they would denote that. So again, it's very similar notation, only now you have an x value. So talking again about vocabulary, the slope of the tangent line, okay, that's asking for the derivative. And once in a while, they'll also call it the instantaneous rate of change, which also relates to your physics as velocity. So just know, if you see any of those things, you should be thinking like, red flag, derivative, derivative, derivative. Okay? So the properties of derivatives, right? We're going to be able to kind of go through and talk about, you can factor things out. Okay, so you can factor out constants. You can factor out the constants. From a derivative, okay? And you can also take derivatives term by term. Remember, terms of a polynomial are separated by plus or minus signs, and you can take derivatives term by term. So can take a derivative term by term. All right. All right. So the first one is the power rule. This is basically for the most simple polynomials, okay? So what we're going to do here is basically it says anytime you have something raised to a power, okay, so here it gives you f of x equals x to the n, then the derivative, again, remember that f prime there, that's notation for the derivative. Basically it's n x raised to the n minus 1. That looks actually more complicated than it is. What does it say in words? Well, to get from this first one to the second one, all you do is take the n out front, okay? So you multiply the exponent by the leading coefficient. In this first example, remember that leading coefficient there was a 1. So you're going to multiply the exponent by the leading coefficient, okay? Then you're going to copy the variable. Sorry, a lot of waiting today. We're going to copy the variable, and then notice that the exponent went from n to an n minus 1, so you reduce the exponent by 1. Okay, so you reduce the exponent by 1. Okay, and that kind of sounds like more work actually than it is in practice. Okay, so we'll take a look at something from the examples there on the next page. So there you have a polynomial, right? You've got just some leading coefficients. It's all in terms of x, right? We don't have multiple variables, but it's asking us to find the derivative of each of the following. Well, the second thing that we wrote was that under the properties of derivatives is that you can take derivatives term by term. So here, this has 4 terms, and we can take the derivative of each term. Okay, well, if I was looking just at this blue part right there, okay, if I want to take the derivative of that, what I do is I multiply 3 by 3, and I get 9. I copy the variable, which was x. I reduce the exponent by 1. That's it for that term. Now you kind of go to the next piece. So I multiply the coefficient by, or multiply the exponent by leading coefficient, so it's minus 4. Ooh, let me rewrite that. Okay. So we have a minus 4, copy the variable, reduce the exponent by 1, but 2 minus 1 is 1, so I don't need to write that. and then I have a plus 5. And notice that if there is a constant term at the end there, that minus 6, when you take the derivative, it's just you don't have to worry about it. Okay? So there's my final answer. That is a lot quicker than what we were doing last class. That is a lot quicker. So if you wanted to even like look back to your notes from last class, the first example that we did, I don't know if I used the same one or not. Okay? So the first example that we did in class last time, I'm just going to kind of jot it off to the side just to show you how much easier it was. So in class last time, we have this example. And you remember, last class, I think it was at least 3, 4, 5, 6, 7 or 8 lines of work to get to the derivative. But now that you know the shortcut, you can say that f prime of x here, well, this times this is 6. This, well, the 1 times 5, 6x, sorry. 1 times 5 is 5. So you have that, and that's exactly the answer that we got last class. Obviously, this way is much quicker. Okay. So let's look at another type of polynomial here. Okay. So we still have a polynomial. This next one's just a little bit trickier. Okay, because we do have some exponents and they are written as a fraction. If you remember your rules from Algebra 2, it said that you were allowed to take fractions, and if you popped the variable into the other part, you would just negate the exponent. So this. And this is where your notation gets important. Okay, so I'm still working with y here, so I'm going to rewrite it as y. I'm just rewriting the polynomial a different way so that I can take the derivative. Okay, so this is just kind of me rewriting it. So I could rewrite this as 2x, but now the exponent on the x is going to be a negative 1. Okay, plus, I'm going to have that 3. When I take that x squared and move it up to the numerator, it's going to be x to the negative 2. Okay, so that was just me rewriting it. And now I can take the derivative, because now it's an easy polynomial, so I can use the power rule, is what they call it. So the derivative, so I'm going to denote it with y prime. Okay, now I'm going to multiply, so it's negative 1 times that leading coefficient of 2, so it's a negative 2x. Now, I reduce the exponent by 1, so negative 1 minus 1 is negative 2 there, so just be careful. And this will be negative 6x to the negative 3. So you probably won't get this one, an easy one like this in the AP exam. But is that the only way I could write that answer? No. No. In fact, if you say this was a multiple choice and you went and looked at the answer choices and that's not a choice, another way that you can rewrite it is by getting rid of those negative exponents and rewriting it as a fraction again. So just so you know, this could also be written as negative 2 over x squared minus 6 over x cubed. Okay? So either one of those answers is acceptable. So just be on the lookout. So if you look at a multiple choice question and your first answer isn't there, go ahead and kind of rewrite it. All right, on a little sidebar, okay, so I'm going to kind of off to the side, just kind of recall your exponent rules. So just down here, recall. Okay, if you have something like, if you had like x to the 5/8, okay, power over root. Some of my students are in there, right? So it's power over root. So that's the equivalent of taking the 8th root of x to the 5th. Okay, and you said I didn't teach you anything. So, okay, so just to recall those rules, we're going to kind of use that to tackle C over here. So again, the first thing I would do is rewrite it, okay? I'm going to write k of t. I'm just going to rewrite it so that it's a little bit easier to work with. So notice there's no prime because I'm not taking the derivative yet. I'm just rewriting it. So if you remember power over root, this is, right, power over root. I'm going to rewrite this as t, okay? But it's going to be to the 7 halves because the power was 7 and the square root implies that the root was 2, okay? Minus t, okay, power over root. So that's my new k, k of t. And now I'm going to go ahead and use my power rule to take the derivative. Okay. So, let's see, k prime of t. Let's see, it'll be 7 halves t. Be careful here. I need to subtract 1 from 7 halves. Good. 5/2. If you need to do scratch work off to the side, then that's what you need to do. Okay. And then it'll be minus 5/3 t. So I need to subtract 1 from 5/3. 2/3. Okay, great. So there's my final answer. Okay. I would say that I would expect the answer on multiple choice to be written like that. I do not think they would go back to writing it in radical form, but could they? Sure. Sure. So just, again, if you look and your first choice isn't there, say, how do I rewrite these rational exponents in radical form? Or how do I take this radical form and rewrite it with rational exponents? Okay? So just make sure you can kind of seamlessly go through those two. All right. And the last one here is D. So we have g of x is 2x minus 5 quantity squared. So those of you that already know the chain rule, you don't know the chain rule yet, so erase it from your mind till next class, okay? So if this is what you had, how would you guys do this now? Well, right now you'd say this is equivalent. Oops, sorry, that doesn't look like a very nice X. Okay? You'd say this is the same thing as 2x minus 5 multiplied by 2x minus 5. Okay. Then, is that a simple FOIL problem? Like, hey, 8th grade, nice to throw back. Okay. So you can FOIL that out. 4x squared minus 20x plus a 25. And now I can take the derivative because now it's just a very simple polynomial and I can just apply that power rule. Okay? So we'll say that the derivative, again that notation, I'm going to use g prime of x. Okay? I'm going to multiply 2 times 4 is 8. Subtract 1 from the exponent on the variable, so that leaves me with an 8x. And then I'm just left with a minus 20. Alright, so you have a few now for you to try. Okay, so hopefully you took a minute to go ahead and try the you try it. So I have the answers for A and B. Notice for C that you can take an extra step to kind of rewrite the original first before you find the derivative. And the same thing for part D. I went ahead and FOILed that out. Don't forget to combine these like terms and then you can go ahead and find the derivative there. Okay? You can pause the video here if you need some more time to review these answers. Alright, let's take a look at example 2. You can read, you can switch it. So, example 2 says, find the equation of the tangent line to the graph of each function at the given point or value of x. Okay? There she goes. So, we have a polynomial here. And at this polynomial, we also have an x value, so that's how this one's a little bit different. Okay? First, we're going to find the derivative. So, to find the derivative, right, I just go ahead and use my power rule. So, I multiply 2 times 3 is 6x plus 2. That's an easy derivative. That's way easier than what we did last class. And so, again, find the equation of the tangent line. So, if I'm writing an equation of a line, I'm thinking in my head, probably y equals mx plus b or point slope. In this case, they're giving me an x value. So if they give me an x value and an equation, could I find a y value? So if I have an x value and a y value, I guess I have a point. And I know that the tangent line, like that's code for derivative, right? So I'm thinking slope is derivative. So if I find the derivative, right, and then I can get a point, then I can go ahead and use my point slope formula. So that's kind of our goal here. So the first thing I did was find the derivative. Well, does that look like a slope to you? No, because it has variables in there. But they gave me an x value, right? So if I want to know the slope of the tangent line, well, I need to plug in that x value. So here, I'm figuring out what f prime of 1 is. So this is showing, again, the notation here gets important because we're going to start getting crazy with all this notation. So this is saying I'm plugging 1 into the derivative. Oh, I'm sorry, negative 1. Okay, so I'm plugging negative 1 into the derivative, and that leaves 6 times negative 1 plus 2, so negative 6 plus 2. I'm pretty sure that's a negative 4. Okay? Pretty sure? Pretty sure. Okay. So, what does that negative 4 represent? The slope. So that is your slope. This is where you have to be really careful on what you're plugging in to things to get your things straight. So if you're plugging into the derivative, you're going to get your slope, okay? So again, just to recall that slope, point slope formula, remember it's y minus y1 equals m parentheses x minus x1, okay? We just figured out that negative 4, so I know that negative 4 goes there, okay? So then I have x, that's going to stay there, minus x1. Well, they gave me the x value, so minus a negative 1 is going to be a plus 1. And then on the left here, I've got y minus y1. Well, how am I going to figure out what the y value is? You plug it in, but where do you plug that negative 1 in this time? To the original, and that's a really important concept. So if you want to get the y value for the point slope formula, you're going to take the x value and plug it into the original, okay? So if I, you can kind of have some side work. If I plug in negative 1 into the original, right, so I've got like y equals, right, negative 1 squared is 1, so I'm going to have 3 plus negative 1 times 2, negative 2, and a minus 1, okay? So here my y value happens to be 0. No, it's not always 0, it just happens to be 0 here. So it's just going to be a minus 0 there. Now again, if this is a free response, this is what I would call a safe stop, okay? You plugged in all your variables, you do not need to simplify it, okay? If it's a multiple choice question, however, the answer will most likely be written in slope-intercept form, so we could go ahead, clean it up, distribute, and that would be a beautiful answer there as well, okay? So that's the equation of the tangent line, okay? That's the equation of the tangent line. Remember, we're going to answer the question asked. Make sure you're answering the full question. I wasn't allowed to just stop at that negative 4. It didn't say what's the slope of it, okay? Okay, so now we have example B here. Here, what I would do first is FOIL that out, okay? Again, for those of you that have already seen this, you don't know the chain rule yet. So we have to FOIL this out. So I'm just going to write this is equivalent to 2x squared plus x minus 21. Okay, and is this the point that you guys were given? What point do you guys have on your paper? Okay, we're going to get rid of that. Okay, we're going to find this at 6, 57. So make sure you change that on your notes. Sorry. That's kind of, I know, like, yeah. Your point. Well, because if you plugged it in, that's what you get. So, okay. I should have done it in a different color. Sorry. So that, make sure you fix that. That was a typo. Okay. And so here. So go ahead and find the derivative there. Again, you're just using your power rule. So 2 times 2 is 4. X plus 1. Okay, so we've got that. Now we want to find the derivative at x equals 6. Okay, so we have an x value here. Now, since we're trying to find the slope, okay, we're going to plug that into the derivative. Okay, so again, kind of make sure you understand what you're plugging in and what you're going to get as a result. So if you plug into the derivative, you're going to get the slope of the tangent. So I'm plugging in x equals 6 there. So 6 times 4 is 24 plus 1, right? So I get a 25. So someone said this one is a little different. So in the previous example, letter A, they gave you x equals negative 1. So they made us go and get that y value of 0. That was like our scratch work up there. But for this example, they're going to give you the whole point. And again, it wouldn't have been, terrible. You would have, 36 times 2 and blah, blah, blah. Okay, that's where that 57 came from. But sometimes they'll give you the whole point, sometimes they won't. It's just an extra step if they do not give you the full point. Okay? And so let's see. Now we're going to go ahead and plug into y minus y1. This time we don't have extra work to do because it was given. Y minus y1 equals m parentheses x minus x1. So we've got that. And if you wanted to kind of clean it up and make it extra beautiful, you'd get the 25x, right? If you have 25, or if you have 6 quarters, right? think about that, and then you're going to be adding 57 to it, so you've got negative 93 there all day if you clean it up. Okay. So, go ahead and take a minute, try to do A and B from the You Try It section. Okay, so at this time you can pause the video there if you need to kind of work them out. And then you can turn the video back on to check your answers. Alright, so let's take a look at what you got for the You Try It. In this first example, you can go ahead and find the derivative right away. So again, I'm going to denote it with G prime. Okay, so you're going to multiply, so you get 3x squared minus 2x minus 1 for your derivative. Then you have to plug in the x value into the derivative. Again, that's going to give you the slope of the tangent line. So if you're plugging into the derivative, that's going to give you the slope of the tangent line. To denote that you're plugging into the derivative, it's going to be g prime parentheses with that 2. That's finding g prime of 2. And if you plug that in, I think you're going to get a, let's see, 12 minus 4 minus 1. And I got a 7 there. And from there, you're going to go ahead and plug into your point slope formula. Okay, it's going to be y minus y1. They were nice this time because they gave me the point, so I didn't have to do any extra work. So y minus y1 equals m. Again, that's the derivative is the slope of the tangent line. Derivative is slope. X minus the x one was there. If this is a free response question, there's your safe stop. You're not going to go further. You're not going to risk an algebra mistake. But if it is a multiple choice question, you will have to go ahead and clean it up. So hopefully you get 7x and you add 3 there, so that'll be a minus 11. Okay, for your answer there. And then for B, you would have had to rewrite that twice and FOIL it out, right? So hopefully when you FOILed it, you got 4 minus 12x plus 9x squared. So then you should find, your derivative, not a g this time, it's a y, so it'll be y prime. So for the derivative, I got 18x minus 12. And then you plug in a 2. Okay. So if you plug in a 2 there, you're going to get 36 minus 12. Okay. So you get a 24 there. And so then your final answer, you're going to have y minus 16 equals 24 parentheses x minus 2. Okay. Any questions on where that negative 16 came from? No. Okay. To get that negative 16, you're plugging in x equals 2, but you plug it into the original. Okay. And then we're going to have y equals 24x minus 32 is your final answer once you clean that up. Okay. Alright, so the next one says, at what point does the graph y equals x squared plus 6x minus 3 have a horizontal tangent line? So let's just think about what that means like in words. Horizontal, right? You know, horizontal is a y equals line, right? Tangent line we know is code for derivative. So basically what this is asking is, you want to take your derivative, because that's the tangent line, and a horizontal line. What slope does a horizontal line have? 0. So really it's saying, when is your derivative going to be 0? Okay? So again, part of the hard part in calculus is kind of figuring out what are they even asking, right? So if they ask you for a horizontal tangent line, which sometimes you'll see me abbreviate as, sometimes I'll just abbreviate it as horizontal tangent line, just like that. They're asking you to take your derivative, set it equal to 0, okay? So first we take our derivative. Okay, so the derivative is going to be 2x plus 6. That's the easy part, okay? So again, because it says that horizontal tangent line, what do I know about a horizontal line? The slope is 0. Well, I know my slope is code for derivative. So that's why I'm going to take my derivative, okay, and I set it equal to 0. And there's a nice problem for you to solve, right? You wish that your life was this easy. So you get negative 6 over 2, so that's a negative 3. Okay? So then the question becomes, what do I do with this number, right? Because this is the x value of the derivative. I need to take that -3 and plug it into the original. Good. So now we take that -3 and we're going to plug that into the original. Okay? So we have y equals -3 squared is 9. And that'll be 6 times -3, -18. And a -3. So that gives me y equals -12. So basically, if I leave it like this, did you answer the full question? At what point? So here's what I want to see. I want to see the horizontal tangent line at, I want to write it as a point because they asked me for a point. So I'm going to make sure I answer the full question, and I'm going to write it as a point. All right. So, one example.
I don't know what this is, but you better figure that out.
So next we have the regular derivative.
There's no numbers. That's not
There's no numbers.
really
Okay.
We have to memorize
here. So, here's what I want you to do, and I want you to put a little star next to it. So this is what you need to know. Sine, cos, negative sine, negative cos. You need to memorize, just memorize. If you always write that down, it's going to be your friend all year. Okay? Here's what you need to know. Write an arrow down and put a D for derivative. Okay? So, I remember in 12th grade, my AP Calc teacher, his name was Mr. Starch, and he'd be like, the derivative of sine is cos, cos is negative sine, and he'd like sing it, and for some reason it's still in my head. So the derivative of sine is cos, the derivative of cos is negative sine. So then this will help you if you're kind of following down there. The derivative of negative sine would be negative cos. Guess what the derivative of negative cos is? Sine. So, if you know that, that's going to make your life easier for the derivatives of sine and cos. Okay? The derivative of sine is cos. Cos is negative sine. Dun, 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 dun. It was like something, tan x is secant squared. I don't know. It was weird because he was like an old man. He's probably really old now. I should look him up to see if he's still alive or teaching.
Go look at the obituary report.
Yeah.
This is all of it. Somebody's mom is going to watch this and then be like, what the heck?
So, if you look, notice the notation here, though. I used a different notation. So the derivative with respect to x of sine is cos. That's what you got there. The derivative of cos with respect to x is negative sine. Okay? So you have tangent. The derivative of tan is secant squared. And the derivative of secant is negative cosecant cotangent. I would say these three are going to be the ones that you see the most. Okay? But it's good to know the other ones, too.
You didn't give us all of them in that little derivative. Yeah.
I know, but these are the ones you're going to use like the most often.
So these are the ones from the test.
Well, I mean, anything is fair game on the AP test.
Do we have to memorize them?
Yep.
Wait, do we need to memorize the ones that are up there?
Yeah, but if you're only going to memorize three, I'd pick those three, but you should know them all.
You're a wicked woman. I know, that's kind of
I am not a wicked woman. Okay?
Like, I'd rather you
So-
just memorize them all. They give you a big to memorize everything. You just want to put it there.
So it says, find the derivative of the following. So again, we're just trying to find the derivative, and our rule for one of the properties of derivatives was that we were allowed to take derivatives term by term. That's good news if you have something like part A here. It has trig functions, but they're separated by a plus sign, so I can take it term by term. Okay? So here, the derivative. Okay. Also, did it say that it said I could take constants out of the derivative, so you're just multiplying by the constant? So the derivative of negative sine, right? So this one's going to be negative 3 cos x minus sine x. So the derivative of cos is negative sine there. Okay, the derivative of sine is cosine, so you're just changing this sine to a cosine, and that negative 3 comes for the rise. Okay? You went? Okay, looking at part B then, okay, that 8's going to come down for the ride, and I'm just going to say y prime. So we have 8, the derivative of tan is secant squared. So you just recopy it like that.
That felt like your little song. Yeah.
I know, I don't have like a trick to remember those, but you do use the sine and cosine ones to know.
We kind of screw up the one from last
I'm sure if you look on YouTube, there's some sort of font or something. Okay.
What was it?
Okay, we have 2 more examples and then we're done. So find the equation of the tangent line to this. We got 2 cos x plus sine x when x equals pi over 2. So I know that we're going to be looking at pi over 2, so I'm just going to kind of sketch out a quick, not a unit circle, but just kind of a quick reference thing. So I know this is a point 0, 1, and then this is also pi over 2. So that's what I think will be important for this. Okay. So first I find the derivative. So if we're finding the derivative, okay, well, the derivative of sine is cos. So the derivative of cos is negative sine. So it's going to be a negative 2 sine x. And the derivative of sine is cos. So it's positive. So it's that. Okay. So there's my derivative. Now, okay, it says find the equation of the line tangent. So if I'm writing the equation of the tangent line, tangent means derivative, slope, right? So to get the slope, I need to take the derivative, check. But now I need to plug into that derivative to get a number, right? Because slope is a number. So I'm going to plug pi over 2 into the derivative. So if I'm evaluating the derivative at pi over 2, that's basically saying I'm going to have negative 2 times whatever sine of pi over 2 is. So sine of pi over 2 is 1, okay, plus cosine of pi over 2. So that's going to be 0. So here I just have negative 2 as my slope. Okay. So now we need to take that to plug into the original to get the corresponding y-coordinate. Good. So we'll switch colors. Okay. So again, if you were kind of thinking of like y minus y1 equals m, right? We have the m value, parentheses x minus x1. Okay, so if I'm plugging in, you'll notice that we're missing that y1. So I'll do a little scratch work to find that. So to figure that out, we plug back into the original. Okay, you always plug back into the original when you're trying to use the point slope formula.
Yeah, girl.
So we do this. It'll be 2 times cosine of pi over 2 this time. Okay, because I'm plugging into the original plus sine pi over 2. So cosine of pi over 2 is 0. So that means this will be a 0 there. Plus the sine of pi over 2 is 1. So I'm going to get a 1. And then I can take that 1 and plug it in to the point slope formula over there. There's your safe stop if it is a short answer. Okay. But if it is not a short answer, okay, your final, well, here, I'll write it out. So you have got y minus 1 equals negative 2 minus, what's going to happen there? Oh, it'll be a plus pi. So your final answer here, negative this, I got a plus a pi, and a plus 1. Yeah, not the most beautiful answer in the world, but that's what we got.
I would find a way to put that plus 1 into one of those other things and get it wrong.
All right, last one. So it says for theta between 0 and 2 pi, for what value or values of theta does the graph have a horizontal tangent line? Again, horizontal tangent line, you should be thinking slope equals 0. When you think of slope, you think derivative. So really what they're asking you to do here is take the derivative, set it equal to 0. So here, the derivative. Well, what's the derivative of theta? 1. The derivative of cosine? Negative sine. So here's my derivative. Okay. And because it's just a different variable. So if this was an x, the variable would be 1. So it's just a different variable. And so now I am setting the derivative equal to 0. So horizontal tangent line, you should be thinking take the derivative, set it equal to 0. And then you're going to have sine of theta equals 1. And how do we solve this problem? Good, this is an inverse problem, right? So you're inversing. This is saying where on your unit circle is sine equal 2, 1. So where on your unit circle is sine equal to 1? Right at the top at pi over 2. So your final answer there is pi over 2. And that is the end.